Hello, Assalamualaikum. My name is Iza Atira binti Ahmad Sirfan and I'm from J4EM 1103E and my matrix number is 2019211798. In this video, I'm going to conduct an experiment called a wheel and axle experiment. So let's get started. Firstly, measure the dimension of the bottles. Repeat the measurements and take average result. Connect 3 wig hangers onto strings. Set the strings to be in tangential position. Measure the distance from the floor level until the end of the hanger as h. The ruler is in vertical position during measurements. Mark a reference line. Rotate the shaft with 1 revolution. Measure the distance of all 3 hangers from the floor. Repeat steps with increment of 1 revolution until 3 revolutions. So this is my result for the table of shaft dimension. And this one is the table for distance travel. To calculate the angular velocity, we can use this formula, which is angular velocity equals to number of rotations times width 2 pi over width times taken. And if we replace the number of rotation with 2 rotations and 3 rotations, the value of angular velocity will be the same, which is 6.28 radian per second. Compare and discuss the results from different types of shafts. So this is the graph for distance travel versus number of revolution for revolution 1, revolution 2 and revolution 3. From the result, shaft 1 with the biggest dimension of 75.0 mm has the largest distance travel for the 3 revolutions compared to the shaft 3 that has the smallest dimension, which is 25.1 mm, has the smallest distance travel for 3 revolutions. This is because the bigger diameter will produce larger distance travel. Give your comments or suggest at least 4 cause of errors that may affect the results of the experiment. Firstly, the parallax error in reading measurements. The positions of eyes are maybe not really perpendicular to the positions of the scale reading of the measurements of measuring tape. Secondly, the wig hangers are not connected tightly with the strings, causes the wig hangers not in equal positions. Next, the shafts are not adjusted properly under the desired position, making the strings are not in tangential positions. Lastly, the ruler is not in a vertical straight position when measuring the distance from the floor level, causes the measurements to be incorrect. Explain how the theories in this experiment give effects in some real-life application, together with examples. Bigger shaft will give bigger distance travel. For example, the Ferris wheel that consisting of a rotating upright wheel with a large diameter. When the Ferris wheel has large diameter, the distance travel of the Ferris wheel will be large also. so the people who ride it will have a much time to play with the Ferris wheel without the need to rotate the wheel many times. Next, another theory for the experiment states that V equals to R omega, which is V, the larger V, which is velocity, the larger omega, which is angular of velocity. This can be illustrated from the tire of a moving car. The faster the car moves, the faster the tire spins. So, larger radius tire, rotating at the same angular velocity, will produce a greater linear speed for the car. In conclusion, to find the relationship between the angular rotation and tangential movement of the shaft, and hence to confirm that V equals to R omega is achieved. This is proved by using the wheel and axle apparatus to determine the diameter of the shafts and the distance travel of the shafts. Bigger diameter of the shafts will produce bigger distance travel. From here, we can calculate the angular of velocity with the relation of radius, time taken, number of rotation, and velocity. One of the safety precautions that can be done in this experiment is repeat the measurements of the axle and discs and take the average result to get the accurate measurements. The experiment can be improved by improving the measurements techniques, such as using the digital ruler during measurements, so the human and the instrumental error can be deducted. That's all for me. Thank you.